Look around you for a second. Pretty much everything, from the lights overhead to the device you're using right now, is powered by something completely invisible. Today, in this explainer, we're going to trace the miraculous, literally near instantaneous journey of electricity, from its very creation all the way to your wall socket.
I mean, think about it. What actually happens after you flip a light switch? For most of us, it's just a mindless habit, right? You flick the switch, boom, the room brightens. But here's the crazy part. Electricity isn't stored in some giant tank waiting for you to use it. No, the power you just demanded has to be generated and delivered almost instantly across potentially hundreds of miles just to power that one tiny action. It's this real-time, on-demand supply chain of physics.
Okay, let's dive into this. Here is our travel itinerary for following electricity down the ultimate electrical highway. 1. Generating the power. 2. High voltage transmission. 3. Substations and distribution. And 4. Powering your home.
So, let's kick things off right at the beginning with stage 1, generating the power, the birth of an electron.
Well, everything starts at a power plant. Now, whether we're talking about a massive hydroelectric dam, wind turbines, coal, natural gas, nuclear reactors, or a sprawling solar farm, they all serve the exact same foundational purpose. They exist to spin a giant generator. It's actually kind of funny when you stop and think about it. Despite our super high-tech modern world, most power plants are just really complicated ways to boil water so we can spin a giant wheel. All that massive infrastructure exists simply to create physical, rotational movement. So why does that spinning matter? Inside that huge generator, you have magnets rotating around massive coils of wire. And thanks to Faraday's law of electromagnetic induction, which basically says that moving magnetic fields create electric current, by spinning those magnets, we're literally pushing electrons down a wire. This right here is the exact moment electricity is born. The mechanical energy of a spinning turbine transforms into electrical energy. But creating electricity is only half the battle. We made the power. Now we have to move it. That brings us to stage 2, high voltage transmission, the long haul. So right out of the gate, we have a massive engineering problem. The electricity leaving that generator is only at a few thousand volts. If we tried to send it as is over long distances, we'd lose a ton of that energy as heat. It would just burn off into the atmosphere, which is totally inefficient. So engineers use a genius piece of tech, the transformer. Think of voltage kind of like water pressure in a hose. To shoot the power across the country without losing it, we gotta pump that pressure way up. First, a step-up transformer acts as an on-ramp, boosting the voltage super high, which mathematically lowers the current and prevents all that energy loss. Later on, a step-down transformer will do the exact reverse, so it's safe for our homes. And when I say high voltage, I mean absolutely staggering numbers. We're talking up to 400,000 volts. You know those massive steel transmission towers carrying lines across cities, over rivers, and through mountains? Those are the heavy-duty electrical highways, and they operate at 132, 230, or even 400,000 volts and up. It's all about moving massive amounts of power as efficiently as possible across vast distances. Let's move to stage 3 and see how this builds, substations and distribution entering the neighborhood. Once the power hits the city limits, it enters a local substation, where transformers start stepping that voltage back down. Actually, next time you're out for a walk, keep an eye out for those gray cylindrical boxes hanging on wooden utility poles, or the squarish green metal boxes sitting quietly beside the road. It's kind of wild to think that these mundane things we ignore every single day are actually crucial local distribution transformers, actively stepping down the voltage of a nationwide network right in your own neighborhood. And the contrast here is just massive. We go from 400,000 volts on the highway all the way down to a super manageable 120 to 240 volts. That huge drop marks the exact moment the power is finally safe enough to leave the main road and hook into your local grid. Which brings us to the finish line, the final leg of our spatial journey. Stage 4, powering your home. So, the crucial point is, the power crosses your property line. First, step 1, it goes through your electricity meter to be counted. Step 2, it hits the breaker panel, which acts like your home's personal bodyguard against dangerous electrical overloads. And finally, step 3, it rushes through the walls to its ultimate destination, powering your lights, turning on your TV, or charging up your phone. Now here is the single most mind-bending fact of this entire explainer. From the spinning turbine hundreds of miles away to the charger plugged into your wall, This entire massive physical journey happens in a fraction of a second. Seriously, the exact moment you flip a switch, that entire cross-country trip occurs basically instantaneously. No way, right? It's just wild. And this brilliantly illustrates the entire journey. Let's step back and look at the whole shebang. The power plant creates it, transformers scale it, substations distribute it, and your home uses it. It is a perfectly synchronized dance of physics, heavy engineering, and everyday convenience. So, next time you casually switch on a light, remember the sprawling, incredible journey behind that simple little action. You're physically connecting yourself to thousands of miles of wire and turbines spinning miles and miles away. So, I leave you with this. Is the power grid the greatest invisible machine humanity has ever built? Think about it. Thanks for joining me on this explainer. Keep asking questions, and I'll catch you next time.